Welcome back, guys. Today, yeah, we left off here yesterday, so we were able to get the token, pass the token, and check the final bits. Finally, we have to pass the address within that, which is an value of pointer. Now we have to interpret this data inside here because we already parsed the beginning token and we found out that it's memory, and then now we are inside the memory, so we check if we are inside memory, and we check if the internal property is a registry value, that is reg, so we check that, and then inside that we would have the actual memory address value. And yesterday when we were looking at the actual chat GPT given code, it has written some random stuff like this. So we have the length and we have the actual name offset, which would be the prop name. So we check it. If it's reg, then we go inside and we actually read the value from p, and inside p it's doing some random stuff like dividing the length by 16 and using that as I value and multiplying it and blah blah blah. I did not understand any single bit of it, and I asked it to explain it. Still I wasn't satisfied actually, so I was just looking at this article that we found yesterday. If you go to the previous stream, we found out an article from this particular thing, and we have this PDF file. And if you go into that PDF file and if you just search and come down to device node requirement, here we have the actual root node, which we can just directly get past it because it's not going to have anything. And then we have alias, and then we have the memory node. This is what we are trying to pass. As you can see, it will have a device type, that is the initial value, that is string, and it will be of memory. So this is what we try to do here. That's it. We get the offset, and we from strings we read that offset, and this string should be no, we are inside memory. Okay, so it's a token. So we are inside begin, and we have the name character, and if it's memory we say we are inside the memory. After we are inside the memory, we have the prop, that is the registry property, because there are other properties too, like there's the initial mapped area property, we have reg property, so we want to read the reg property. So that's why we go there, we read the string offset, and inside string we offset it and we get the string, and if it is reg, then we are inside the registry property. Now we can actually read the value. And what is this value supposed to be? It consists of arbitrary number of address and size pairs that specify the physical address and size of the memory range. So we have some examples. Let's say we have a 64-bit physical layout with RAM starting from 0 and length is 2 GB. Then it should be like this. So the device type will be memory, and reg will be starting address is 0. We have to interpret this as a one whole 64-bit. So this entire thing is representing 0, and this entire thing is representing the size. Now we have another example, that is, it is starting from 1 2 3 1 2 3 4 5. So it's how many zeros? 3 4 and 4. So it's like this entire block is 0 and we have 1 in this block. So this is the entire address, and we have the and it's 4 GB. So there is a 1 here and this entire thing is 0. So this is how it's going to be. That's why we need length, because a single memory can have as many memory regions here, because so if that's why we have this value. We read the length and the string offset. So if the length is 4, then we are supposed to read 4 different 32-bit pairs. So in this particular case, the length will be 2. So we'll be reading 1. This is the one full 4 32-bit pair, and we have the second 4 32-bit pairs. So and 2 of it is address cells and 2 of it is size cells. Okay. Okay, this is how it's going to be. So we need to, and this is what I asked to ChatGPT too, but it was so fucking stupid. See what it actually told us, because this is why I don't believe ChatGPT, because ChatGPT is just a search tool. It really does not understand anything, because you can see I asked it like using shift. I'm like I wanted it to change it to shifting method. That's fine. I also gave this example and I asked it like specification says that it's arbitrary number of addresses, but the example shows only two 32-bit addresses of two size. Now it just justified my statement, and it said well, I guess I again asked the same question. So a single entry can have 4 32-bit value, right? Yes, that's fine. No, wait. I also asked one more thing. Yes, a single registry can have multiple entries. So, and when it actually and one memory registry, it will registry of 4. I mean, like somehow this answer was a bit confusing for me. If I hadn't read this part myself, I think I would have been completely lost if I were just was reading this fucking thing. Only because I had this context, I was able to interpret this in a better way, because it was throwing in a lot of stuff which I didn't understand. But here it was simple, and you have 2 examples, and you can just you have to know, because it's we also have an example saying that a registry with just a single entry and a registry with a single entry, and we have an registry with 2 entries. So it is possible for a registry to have multiple entries. And I think even he has implemented it in that way. I don't remember exactly. Let's double check it. Yes, up to length. So he is going to read up to length. So whatever length it is, he is going to read till that. So we also have to do the same fucking thing. So we need to read till length. and the length is going to be different a little bit. Okay, now I have a question. Does the length actually say the number of registers, or does it say the actual 32-bit entries? So is it like the length will say there is 2 registry entries, or it will say there is 8 32-bit values there? I think it's going to say there is 8 32-bit values, because from what I remember, everything within this documentation, everything within DTB should be 32-bit units. I think so. Somewhere I read it. I believe so. I'm not now. I do have a little bit of confusion here. Let's ask ChatGPT then. So we have the length. Let's give this context. If not, it will just throw in random gibberish. That's not good for us. So the length, does it say how many reg values are there, or it says how many 32-bit values are there? So in this example, is it length 2, example 1, I guess? Is it length is reg length 2, or is reg length, what is it, 8? As in, I don't know if it understood the question. I don't know if am I asking it wrongly, but I do have this question, so let's see, because I need that information, so only then I can come to a conclusion of how I can implement it. Length refers to the bytes, not the number of entries. So length is going to be, and it tells how many number of bytes in registry array. What is the bytes? Each entry is 16 bytes, that is 4 into 32-bit cells. So it's going to say it's 32 bytes. Oh, okay. Not 2, not 8, it's going to say it's 32 bytes. Oh, that's why it used the length by 16. So in the initial example, it did use length by 16, but it didn't explain any of this shit. It just wrote it. How am I supposed to understand it by on my own? Even this documentation did not explain it properly. It consists of arbitrary number of addresses and size. Where's length? Oh, length is supposed to be in, I guess it's supposed to be in the root node. Wait, where did we parse the length? We are reading length. We are reading length inside the token. After the token. Because we come here, because we just read that the token is prop. The next bytes are the length. So it must be in the entire, be in the metadata itself. So we need to find it somewhere in this documentation. That's too fucking hard. So let's just move on. Okay. So now I get it. So we can assume the length should be divided by 32. Let's divide the length is by 16. As length is the number of bytes, and for 32-bit entries means 16 bytes. That is 32-bit entries equal to 16 bytes. Hope I'm correct. Okay, now what can we do? Now we have the actual calculation. Now we can just use a for loop. So let's say int u int 32 I equal to, no, we can use max length. That would be length divided by 16. We also have to check if length is greater than 0. If it's less than 0, what do? There's nothing there. What the fuck am I supposed to do if there's nothing there? That's an annoying case. What would I do? What the fuck would I do? Guys, let me change my chair position. It's so fucking annoying here. Okay. What would I do? So we have what do we have? Let's think. If there is 0 value, then there is no memory. So we can just directly return 0. Is it possible? Because we don't even have to do anything here. Because we know that we tried to pass that DTB and we got into somewhere. We found the tokens, we found the nodes, we came down, we parsed down, and we are here, and the length is equal to 0. Or it can't be less because we are reading it as an U32 value, so it's unsigned. It should not be less than 0. Maybe just to be fucking sure, we can put less. You can put less. If the length is less than or equal to 0, then we can just return 0. We don't have to care about anything else. We just return 0. Okay, that's good. I hope it's fine. Yeah, we can't really do anything because our function is just to get the total RAM. And now we have the max value. Now we can write the function. Let's put for uint 32I equal to 0, I less than max. Should we go to, because we are starting from 0, so it should be less than max, not equal to, and I plus plus. We want to read the first entry and we want to read the second entry, at least in that example. Okay, I think we are fine. Okay, now what do we do? Okay, now we need 4 32-bit values because there are 4 32-bit values. So take this as an example. We have 4 32-bit values. We can read them one at a time from this location. From this location, where is it? Oh, from this location, that is just P, we can read one at a time and we can increment the P value. Yes. And for every iteration, we can increment the P value by 16. Or it's 16, right? Because it's 32 bits. And if we are reading one 32-bit, we are incrementing it by 4. We read 16. We read, no, how many? Oh, I'm fucking confused. How many bytes do we read? We read 32, 32, 32, 32. So we read 4 32s. So we increment P by 16. That's it. Why the fuck am I complicating this? It's that simple. We just read it. Read one at a time. We can read 4 values. Let's just copy this because we can use the same thing here. No. Then we can just put it like this because after every read we can increment it by 4. That's it. You can maybe write a helper for this, but it's fine. Now we get into this. We read the first value, which should be will be going from right to left, no, left to right. So this will be higher 1, HG1, and this would be HG2, and this would be LG2 and LG1. Then how would this be LG1? You fucking moron. Yeah, I guess this is how it will be because we are reading from left to right and reading from here to here. Oh, if we are reading from here to here, then this is one value, this is another value. Fucking God, I'm fucking confused. But I think it's fine. This will be the address higher, and this is address lower. This is size higher, and this is size lower. I think this is correct. It should be correct. Now we can just group them into uint 64 of How do I need to I need to take a UN64. Let's take UN64 as 0. UN64 as temp value, that is 0. And if I take 0, if I take temp and I left shift, I need this in the upper half. This should be in the upper half, this value. So I need to then why the fuck do I even need this? I can just put ADD2 and shift it to 32. That's it. Now we have the upper limit of address. Okay, I guess I can put another bracket here and put a R here and put ADD1, because ADD1 is already in the correct position. We are shifting 32. I think I'm missing something, but I don't know what I'm missing, because I feel like this is a higher address, so it needs to be shifted 32 bits. And then we have the lower address that we can just keep here. And we can cast it as UN64. I believe it should be correct. I don't know. Let's see. Let's just finish it off and give it to ChatGPT and make it rewrite it properly. But we just need to understand the core idea of what we are doing so that we can debug it if something goes sideways. And size 1. And we have the address and a size. This will be for the first iteration. However, where will we store this if there's multiple things? Oh, no. We just have to add it because we want the total RAM. We don't want the we don't want slices of it. We just want to understand the overall size of the RAM. Okay, I get it. So we can just have a total UN64 total equal to 0. And we can just add total plus equal to size. Once it is done, be written. Total. Total. We still have to take care of 2 more props, but I think that should be fine. Okay. Okay, I believe it's fine. Let's just see what the mistakes we have done. We don't need this helper. Let's read 16, 64. Okay. How about this? Let's see. Mistakes based on how GPT writes the same function. You are very close and you have 4 fucking critical bugs. Oh my fucking god. Okay. I forgot to swap 32-bit values. That is to say, this swap, because it's in different ordering. Okay, that's one mistake. Fine. Yes, these are two 32-bit integers. Oh, fuck. That's why I thought I needed a temporary 64-bit value. So I'll have a higher half. So I can push it off to higher half. Something like that. Other stuff, it's yet to be written. Leave those. We only want to fix. No, I don't like your approach. Oh, we cast it as 64 and then we shift it. Okay. That was the missing part because I knew something was missing there. We just cast it as 64. We don't have to cast it here. We just cast this as 64 and this as 64. We cast this as 64 and this is 64. And we are good. Okay. We don't have to explicitly mention it because we have it here. And most probably, why do I have this many brackets? Something is wrong. It's here. What's this bracket supposed to do? Okay, it's for this. Okay. I'll find then it's correct. Okay. Now we also have to shift this. We are reading 32 bits. I think we are doing the shifting here. Yeah. So I think we are fine. Because we are reading that bytes as P and we shift it. So we are fine. We don't have to do that part. So we are good. I think our implementation is fucking fine. We just passed DTB and got the value. Now we also have to make sure if we are not in a memory node, we move past this prop. That's an important thing. How do we know that? How do we know that we actually have something? Maybe we can put it like if max and total then we can return total. If this is not the case, would we be inside this? I don't know. We are inside a if condition. So I think if we are inside this, we should just return, because there's no other possible scenarios. But if we are not inside the if condition, then it's possible that there's some other prop. So we need to move past that prop. How do we do that? We just move past this length. I think that should be fine. Yes. We can put a while. Temp u into 32 temp equal to length. Now I need to increment p every time. I also have to so I need to do two things. I need to increment p and I need to decrement temp. If temp greater than 0. If temp is greater than 0, I move past that value, and I also yes, so the next time when we read it, we'll be past this token value. I think it's good. Yes, it should be good. And then we can break, because we only care about memory and reg, and that's it. What about other cases? If there's another case, we also have to move past that, I guess. That code was a long time ago. Because we also have to move past those two tokens. We could just write p plus length. I'm so fucking stupid. And we have to align it to 4. Other than that, for everything else, we are just breaking. Oh yes, I'm in a dire need to leave now. I'll join later, some other time. Have fun. I guess we are done with the parsing. I'll test it once again, but I think it should be good. Yes.